The previous one, what had to be the same? The perimeter, right? So now this is like me coming to you and say, hey, I want you to make, on the ground with some string, I want you to make a rectangle with an area of 20 square feet, okay? You make yours, everyone's going to make their own, okay? The only condition, it has to have 20 square feet. That's the only condition. I'm not giving you a limited amount of string. I'm just telling you to make 20 square feet total. So let's just look at a couple of different ways we could do that. What's one way I could do it? That would work, right? That would work. That would have an area of 20, wouldn't it? Now what's my perimeter though? How much string did I use to make that? I used 42 feet, right, would be my perimeter here. Someone give me another way. 5 and 4? 5 by 4? Something like that? That would have an area of 20. What's the perimeter of that one? 18? 18 feet would be your perimeter. Y'all buy that? I want you to find the dimensions of a rectangle that has an area of 20 square feet but has the smallest perimeter possible. Pardon?
2 and 10.
2 and 10? Would that work? 2 and 10? 10, 2, that's 20, right? What's the total perimeter? 24, right? So which one so far has the smallest perimeter? The 5 and 4, right? So again, it depends on how you do it, right? Now, could I do this? Just watch. Could I do this? (200 by 1/10). Could I do that? What's this times this? What's 1/10 of 200? 20. So does it have an area? Yes? Okay, but how much rope did I use? 200 plus 200, that's 400 plus a tenth and a tenth. It's a lot, isn't it? It's a lot. But I could do this, yes? Could we do that in the previous problem? Could I make that rectangle in the previous problem? No, why? I only had 20 feet of rope here, right? Here I've not limited your rope. I've just made the condition that your area must be 20. Yes? You think it's root 20 by root 20? That is what it is. But again, this is a basic problem that logically I think it makes sense that it should be a square, right? But trust me, we're going to move to other problems where you can't like just deduce it that way. So, but it's good. All right, everyone see the difference in this problem. Not a fixed perimeter. This time our perimeter can be whatever. It's a fixed area. So I'm going to start with my objective. What's the objective? What is the thing we're trying to find the biggest or smallest thing of? Perimeter, right? Okay, so the objective, this is the way we write this, is to minimize, I'm going to say P, since you understand minimize perimeter, right? That means I need a formula for P. And the formula for P is going to be based off the picture of a rectangle that has been pretty generic at this point, L and W, right? So the perimeter is what? 2L plus 2W. I would like to know when I can make that as small as possible. But right now, my perimeter depends on two different variables, doesn't it? L and W. It'd be great if I could turn this into a single variable, then I could use calculus, right? How am I going to get it to a single variable? I need to use the constraint. And what is my constraint? Somewhere in the problem, I'm constrained. I can't just let anything be anything. There's a constraint of what? The area has to be 20, right? That is the constraint on the rectangle. You have to have an area of 20. That's the directions, right? What is the area of that rectangle in terms of L and W? It's just L times W, isn't it? It's 20. And then what can I do with this? Solve for one of these. Which one do you want to solve for? L, let's solve for L again. L is 20 over W. And what am I going to do with that? Plug it in over there for L. So now my perimeter becomes 2 times 20 over W plus 2W. That is now a function of a single variable, isn't it? P now depends on W and W alone. Now, unfortunately, I'm going to write P of W. It's going to be 40 over W plus 2W. But I have accomplished the main task, and that is to somehow turn this word problem into a function of a single variable. And now I get to attack that with calculus, right? We need to determine whether or not we're working on the closed interval method or the open interval method. So are there any restrictions on W here? Pardon? It can't be 0, right? It can't be 0. Why? If W is 0, your length is undefined. In fact, if W is 0, you have no area, right? If W is 0, you have no area. And what's the requirement? You must have an area of 20, right? So W can't be 0. Can't be negative. Is there a maximum size for W? Was there a maximum size for L? Remember, I did 200 by 1/10. Could I have done 2,000 by 1/100th? Sure. Could I have done 2 million times something, right? I could have. So there is no restriction. All I know is that my W in here can't be 0, and it can be as big as I ever want it to be. And you cannot use the closed interval method for this. You see? So the problem itself is going to dictate which of the two methods you're going to use. The good news is that this is kind of what we've been doing today. So what I'm going to do is I'm going to go through the thing where we take the derivative, we find the critical numbers, we draw a number line, and what we're going to be looking for is what on that number line? We're going to be looking for down, then up, right? If we see down then up, then we will have found a minimum, right? Okay, so open interval method now. So I want to find the minimum, right, of P. There was something else I want to say. Oh, let's take the derivative. Okay, what did I do there? That's my derivative. What did I do? You could do quotient. I rewrote the 40 over W as 40W to the negative 1 power. Right, this means this, doesn't it? And then if you take derivative of this, the negative 1 comes out, and you subtract 1 from the power, it becomes negative 2. And I took that and dropped it back down. So that's where I get this from. Is that all right, everyone? Everyone's good? And then derivative of 2W is just 2. And now what am I going to do with that? Set it equal to 0. So take that, set it equal to 0. So I take negative 40 over W squared plus 2, set that equal to 0. And this is where I've said there's all these different ways you could solve this. There's some really easy ways, but I'm going to still stick to the way that I like to do it. I'm going to get a common denominator between these two. I like to do this because I think it's just a skill that the more you do it, the better you get at it. This becomes minus 40 plus 2W squared over W squared equals 0. So all I did there was multiply the top and bottom of this 2 by W squared so that they have the same denominator, and then I put them together. A fraction can only be 0 when? When the numerator is 0. So minus 40 plus 2W squared equals 0. And then that, I think, should solve pretty clean now. I just move 40 to the other side. 2W squared equals 40. Divide both sides by 2. W squared equals 20. And then that means w equals plus or minus root 20. But I'm throwing one of those out. Which one am I throwing out? The negative, because the width of my rectangle can't be negative. So w is root 20, right? Which is what we said it would be. So are we done? Why am I not done? Am I done? I need the length. What did I ask for? I said find the dimensions, right? Okay, so could you find L now? Right there, right? Okay, hold on. You just lost a lot of points on the test. You have not proven to me that that's a minimum. All you've done is shown that you found a critical number. You still have to prove it's a minimum. How do you prove to me that's a minimum? Number line, test points. Don't forget that step. So many students on a test will do this, box it up, they'll get L. It's the correct answer, but no way have you shown it's a minimum. So you have to show it's a minimum value. So to show it's minimum, I do a number line, root 20, and then I can pick any numbers here and here. And, oh yeah, I should have mentioned, why are we not looking at, where's the derivative not exist? Sorry. Where does the derivative not exist? Here's a derivative, right? What would cause a problem here? 0. But is 0 in the domain of our function? No, so I don't need to worry about it. So no worries here. Okay, 4 and 5, okay. Could you have done 1 and 100? Yes, whatever you want. I don't care what you do. 4 and 5 will work for me. You've got to plug those in where? Which one? Derivative, right? Because you're trying to figure out if it goes down or up. What are we hoping for? Down, then up is what we're hoping for. If it goes up and down, you have not found the minimum, you found a maximum. So let's plug 4 in. 4 squared, it comes out to be negative, so it goes down. And if you plug in 5, it comes out to be positive. I'm not showing the work, but it is a minimum, all right? But you have to show that step. These two numbers are going into the derivative, and you're calculating that and figuring out that it's a negative number followed by a positive. So if w equals the square root of 20 and L equals, where do you get L from? L is this, right? Yeah. It's 20 over root 20, isn't it? Then we have the minimum area. No, sorry, minimum perimeter. Shit, what am I saying? Perimeter. Do I know what the perimeter is right now? Do I know what the minimum perimeter is? I haven't calculated it, have I? Could I? Yes, I could just very easily put W into my perimeter formula, and that would give me the minimum perimeter. I thought you said it was going to be root 20 by root 20. It is. It is. Just I want to make sure everyone understands it is, right? If I rationalize this, right, what happens? On the top you get what? 20 root 20, and then on the bottom you get 20, and the 20s cancel as root 20. It's one of those weird things with roots that root 20 over or 20 over root 20 is actually root 20. It just looks weird.
But for this problem, if it asks you to find like the biggest perimeter, you can't do that because it goes to infinity.
Very good. Yeah, if you were asked to find if you were told that the area of a rectangle was 20, find the dimensions that give you the maximum perimeter. There is no such rectangle that exists, because you could make it a trillion long and infinitesimally thin and still have an area of 20, and then someone else could do like 2 trillion long. So, yes. Oh, right here, back in the constraint equation, remember we solved for L? That's where you'll always go back to figure out the other variable. Your constraint should be solved. Okay. Do y'all feel like y'all are kind of getting this a little bit? A little? Are you all ready to work on one? No, and I'm seeing no. I don't want to get into the other ones yet because I said if this is going to be on the test next week, that I want to keep the problems at a certain level. So let's do this. All right, let's work together on this, all right? And I'm not sure if I'm going to take it for a grade yet, but do it on separate paper just in case. I may not take it today. I may take it at some other point when you're begging for points or something. I'm like 2 points away. I need 2 points. Just have this saved, all right? So it's okay for you to work together on this, all right? What we want to do is I want to build kind of like a rectangle like before. But for this one, it's actually going to be four identical rectangles like this. And think of this more like we're trying to build fence, like fencing to put some animals in it or something like that. And we're looking at this from the top down. Okay, so like these are like little pens for our little chickens or whatever we have, right? And we want four identical pens. Right? Four identical pens. Four identical pens. That's one of the conditions, right? We have to have, they all have to be identical. That means same dimensions. Four identical pens. You have 320 feet of fence. I have 320 feet of fence that I'm going to use to build these pens. I would like for you to find the dimensions which maximize the total area. And then after you find the dimensions, I want you to tell me what is the maximum area. So this is the same problem as the one we started this whole idea with, where I said if you had string and you laid it on the ground and made a rectangle, that everyone does it different ways, we're going to get different areas. If you have 320 feet of fence, there's a bunch of different ways you can build this, right? But I want it built in a way that you get the maximum area. Yes? Total area, which I think you could ask yourself, like think about it. If I wanted the total maximum area of everything, then you could look at the whole thing or you could look at just one. It's up to you because... Oh, your final answer, total area. Yeah, sorry. Okay, yeah. So what is the max total area? All right. Yes?
So whenever they're separated, like, are they like four separate pens or is it one?
No, this is like one big pen that has partitions down the middle. So you need fence. Everywhere you see black lines, you need fence. And you don't need to these don't need to be doubled up, right? These are not doubled up. You can use this wall for both pens. Understand the problem? All right. Have at it. Help each other out. Work together. See if you can come up with something. I think, because of time, I think I'm going to stop the video here and I'll answer some questions after y'all have a little time to talk together.